Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on August 12, 2025, about 1 week ago. The big hook is an integrated system that delivers real-time interactive video at 1080p and 60 frames per second, with frame-wise action control, cross-domain prompt blending, and on-the-fly editing. The paper is titled YAN, Foundational Interactive Video Generation, and as we'll see later, the results are surprisingly cohesive at high speed. In short, this paper unifies simulation, multi-modal generation, and editability to push interactive video beyond isolated demos toward practical creative tools. Building on that, the tweets highlight classroom uses, physics experiments with ramps and friction, history scene annotations, chemistry pre-lab safety drills, and civics role plays using interactive replays. Engagement appears modest. Alright, this overview figure lays out the system's 3 pillars. At the top, the simulation rows show real-time infinite play at 1080p and 60 frames per second, plus accurate mechanics like bouncing board jumps. Moving down, the generation panel demonstrates 4 modes: text-to-interaction, text-guided expansion, image-to-interaction, and cross-domain fusion that blends styles and rules. Finally, the editing panel separates structure edits from style edits, so users can add objects or change materials mid-interaction and keep gameplay consistent. Okay, this overview diagram stitches the pipeline together. On the left, an agent explores the game world, filters and balances trajectories, then outputs synchronized observations and actions. In the middle, automated labeling generates structured captions using a vision language model and estimates depth with the depth model, while mixing in out-of-domain images. Moving right, these inputs plus action signals feed the unified system, which then branches to 4 experiences: real-time simulation, image-to-interaction, text-to-interaction, and interactive structure or style editing. Next, this table compares interactive datasets on 5 axes: resolution, frame rate, whether actions are aligned per frame, action space size, and total scale. The key point is that the new dataset offers 1080p at 30 frames per second, with frame-wise action labels, 8 distinct actions, and 400 million frames. In contrast, prior sets trade off either resolution, frame rate, or alignment, and several are much smaller in scale. Now, let's walk through the YAN sim diagram. The top pipeline shows frame-wise inference. Initial frames get compressed by the visual encoder, a noisy latent is concatenated, then action signals and a key value cache guide YAN sim, and the visual decoder reconstructs the next frame. Building on that, the lower left panel illustrates shift window denoising, where cache keys slide forward across time to cut latency. Finally, the right panel breaks down attention: spatial attention, action cross-attention, and causal temporal attention. Now, this architecture focuses on YAN-GEN, showing how multimodal conditions steer frame generation. Start by looking across the whole diagram. Noisy latent tokens enter, pass through YAN-GEN, and decode into frames, with a key value cache enabling infinite autoregressive rollout. Zooming into the lower block, decoupled cross-attention lanes inject text, image, and action signals separately, alongside 3-dimensional self-attention and feed-forward layers. Building on earlier steps, this separation enforces style alignment, while the action lane provides precise frame-wise control. Building on that, 2 takeaways stand out. First, the system delivers real-time 1080p at 60 frames per second with frame-wise action control, thanks to a compressed 3 dVAE and key-value cache shift window denoising. Second, disentangling structure from style enables on-the-fly edits without breaking mechanics. That is it for the AI Research Roundup. I am Alex. Thanks for listening.